All right. Good afternoon, good evening, or probably good morning, depending on where you are watching this short video from. Now, today in this class, we are just going to be considering how to determine scales for physics practicals. How to determine scales for physics practical. Now, if you look at the screen properly, you will notice that we have a graph, but not actually a typical YX standard graph. If it's a typical YX standard graph, on the vertical axis, we are going to be having 12 boxes. Like you have where you are seeing this. So this 1, this 2, 3, 4, 5, 6, 7, 8, 9, and 10. If it's a YX standard graph, it's supposed to extend to 12. Now for your x-axis, you are supposed to have 10. But because this is not a YX standard graph, we're going to be having less than that. Now if we count, this is 1, 2, 3, 4, 5, 6, 7, and 8. Now this particular graph that we have here, this graph is a 10 by 8 graph. It's not a YX standard. If it's a YX standard, we are going to be having a 12 by 10 graph. That's what we're going to have. 12 means 2 centimeter boxes along the vertical axis or your y-axis, and 10 centimeter and 2 centimeter boxes of 10 along the horizontal axis, as you can see. But in this particular class, now even in your typical physics experiment graph, is even of is it's important that you should just make up your mind to know that, okay, if you are plotting the graph, you are just going straight for 2 centimeter. Don't bother yourself about 1 centimeter because of the range of values that we typically have. In your physics practical, you will not have data values to plot that is beyond 6. So because of that, 2 centimeters is perfect for the scale that you want to typically plot in your physics practical examination. Now, with that being settled, let's quickly consider the formula that we will use for it. Now, if you want to plot your physics practical graph, as you can see on the screen, the formula for determining scale is your highest value divided by the number of boxes. Remember, we just talked about the number of boxes from the graph that you can see here. Like we said, for your typical YX standard graph, on the vertical axis here like this, you are supposed to have 10, 12. You are supposed to have 12 of 2 centimeters in dimension, while on your horizontal axis, like you have here, you are supposed to have what? 10. Now keep that in mind. Now if you look at what we have here, now for your y-axis, if you can see the screen properly where my cursor is, for your y-axis, the number of boxes you are going to be having is 12 for a 2 centimeter scale, and 24 for a 1 centimeter scale. Now remember, I just said that we are not going to pay attention to this 1 centimeter scale because the data value we are going to plot usually is within 6. So it's advisable just to go with 2 centimeters. So we are just going to be using 12 boxes. Now for your x-axis, the number of boxes sorry, the number of boxes you are going to be having is 10 for 2 centimeters and 20 for 1 centimeters. Again, we are not paying attention to the 1 centimeter, so we are just going to ignore this aspect of it. So that typically means that in this class, we are paying attention to 12 boxes for 2 centimeters on the y and 10 boxes for 2 centimeters on the x. Now there is something to note why you are still considering this. Now note, the highest value to be plotted must not have more than one non-zero digit. If it does, the first non-zero digit is increased by 1, while others change to 0. Now if you look at what we have in this particular example here, now we have 15. Now 15 has 2 digits that are non-zero. So what did this note says we should do? You will increase the first digit, which is 1, to 2, and you will turn the 5 to what? To 0. In the case of 11, it's 2 non-zero digits. So you increase the first one to 2 and you turn the other one to what? 0. Now in the third example we have here, we have 101. Now we have 2 non-zero digits. We make the first non-zero digit, we increase it to what? To 1. to 2 rather, and we turn the other ones to what? 0. Now this is not a conventional what approximation, but if you understand what I'm doing, it would have helped you a lot. Now let's consider an example to see how we use this formula. Now we are supposed to plot a graph. In this case here, we are to plot a graph. In this particular case, we are to plot a graph here now, a graph of we are to plot a graph of mass. We are to plot mass against AY. So we are plotting, if you come down here, we're actually plotting, just give me a second, so let me remove this thing that I have on the screen here. Okay, now we are plotting, we are going to be plotting the graph of mass against Y. Now we are plotting M against what? Y. Now using the formula that we have, now if we're going to use the formula that we have now, now let's consider the space that we have. Now for our y-axis, now, the highest value is 0.506. Now remember we said we only need if we have more than 2 non-zero digits, what we are supposed to do is to increase the first non-zero digit by 1 and turn every other one to what? 0. In this case, we have 5 and we have 6. So what we do is to increase the first 5 by 1 and make every other one to turn towards 0. So this one will be approximated to what? 0.600. I believe you understand what we are doing now. Now remember that the formula for our scale, now our scale now is the highest value. What is the highest value now? 0.600 all over the number of boxes. Now the number of boxes is actually what? A maximum of what? Of 12 if we are working along the what? Y-axis. Now our aim here is to keep dividing what we have, starting from what? Starting from the highest value, and we'll keep reducing it as we move, meaning we start from the highest, which is what? 12, we move down to 11, like that, to 10, and we'll continue down the line like that until we have a perfect scale. Now what is a perfect scale? Now in your typical physics practical, your perfect scale is 1. Your perfect scale is 1. It's 1 and its combination with 0, meaning we can have 1, we can have 10, we can have 0.1, we can have 0.001, we can also have 100, and so on and so forth. But remember at the back of your mind that we cannot have 1 combined with any other digit if you are actually trying to determine your scale. So what we are doing is this. So the same thing that applies to 1 is also what is applicable to to 2 and 5. So simply put, in your physics practical, your proper scale, as it were now, your scale now must take values such as, for example, you have 1, you have 1, you have 1, its combination with 0, which is 0.1. We have 10, we have 0.01, we have 100, and so on and so forth. We also have 2, 0.2, we have 20, and so on and so forth. We have what? 5, we have 0.5, we have 0.5, we have 50, and so on and so forth. Now if you get what I'm trying to say, it will do you a lot of good. Meaning, in your physics practical graph, your scale can only take 1, 2, and 5, or a combination of 1 with only 0, either in decimal form or in multiple form. In multiple form, we're having like 10, 100, 1000. In sub-multiple form or decimal form, we are looking at 0.1, 0.01, 0.001, and so on and so forth. Now the same thing that is applicable to 1 is also what is applicable to 2 and what is applicable to 5, meaning the only 3 known zero digits that is expected to be seen in your scale are what? 1, 2, and 5. If they must combine with any other digit, it has to be what? 0. Now, if that is well understood, now let's quickly determine the scale for the y-axis as we're doing. Bearing all these things in mind, now let me quickly remove it so that we can determine the scale for the y-axis. Now, if we divide what we have here, we already have 0.600. Now, if I divide it by 12, which is the highest value for our y-axis, this is going to give us 0.05. Now, because this is a good scale, that is what we are going to be using. Remember, we said a scale can only take 1, 2, and 5, or their combination with 0. And if you look at what we have here, we have 5 combined with what? 0. So this is a good scale. Remember that 12 boxes actually what? Connote what? 2 centimeters. So this scale will just be what? 2 centimeters equals to what? 0.05 what? Gram on our what? Y-axis. Now, 0.05 on our what? Y-axis. Now, let's quickly look for that of what? Of x. Now, if you look at the x side, for the x side, we have the highest value we have there is actually what? 130. Now, again, in this value, we have two non-zero digits as 1 and what? And 3. So what we do is to increase the first one by 1, which is 1. 1 added to 1 gives us 2. So this one becomes what? 2. Every other digit is what? Approximated to what? To 0. Now the highest value here is what? The highest value here now is 200. So what do we do? Using the formula for scale, we are going to divide what? This 200 by the highest value on the x-axis, and the highest value there is actually what? 10. We are talking in terms of what? Boxes. Now let me still take us back to the graph so that we understand what we are saying. Now remember that what we mean by the number of boxes, one square like this is actually what we are calling what? A square this way is actually what we are calling 2. A square that way is, this square is actually what we are calling let me show us now. This square is what we are calling what is it called now? A square like this. If you look at my cursor, this square is what we call what? 2 centimeters. One big square like this. Now for your x-axis, we have 10. Remember that we said a typical YX standard graph has what? 12 boxes of 2 centimeters width along your y-axis and 10 centimeters width along your what? X-axis. Now during the scale, we start dividing from the highest value and we keep going down until it gives us an appropriate scale in terms of what? 1, 2, or 5, or their combination with what? With 0. Now let's continue what we are doing. Now remember that the highest number of boxes we have on the x-axis is actually what? 10. That is actually what we use to what? To start. Now this one, if divided by this 0 here, we cancel this and we are going to be having what? 20. That means on the x-axis, our scale will be what? 2 centimeters to what? To 20 units. 2 centimeters to what? To 20 units. Now simply means if we are plotting this graph, we would have used what? We would have used 2 centimeters to 0.05 gram on the y, and on this other side of the x, we would have used 2 centimeters to 20 units on the what? On the x. Now this is how we actually what? Determine what? Scale in physics what? Practical. Is very easy if you understand what I've explained. Now please do well, if you have not subscribed, to subscribe to this channel, and if you have any question, please kindly drop it in the comment section. You can ask any question and I will do well to respond in due course. Thank you and see you in our next class.